This is our last speaker before our math poll. This is Chris McCarthy. He's from the Borough of Manhattan Community College, and I've been blessed to know him for a number of years. We met at a poster session that I was giving, and he came up and started talking to me. So when you go to these meetings, you just never know what kinds of friendships, and it's because of him that we have the Scudem competition. He mentioned that they have the ACM has computer competitions, and why don't you do something like that in Simiode? Now, I didn't quite hear the way he said that, but what actually he said was, why don't you do something in Simiode? And so we have been doing that, but it's all been thanks to him. So Chris, take it away on your student projects.
All right, thanks, Brian. And what he says about meeting people is absolutely true. It's been a wonderful friendship with Brian and with other people I've met. Okay, so my talk is going to be on student differential equation modeling projects, and I teach at BMCC, and my thing's not working. Let's see. Okay, so this is a picture of my school. It's located in Lower Manhattan, right on the Hudson River. And it's a pretty big community college. We have more than 27,000 students and over 45 associate degree programs. Students come from over 145 countries. It's a very, very mixed group. There's no one type of student that dominates. That we have like a little bit of everything, okay, which is very nice. And we have a very large math department. Now we're maybe like 80 math professors or so. It's a very big department. Okay. And here's a picture of where we are. We're in Lower Manhattan. And let's see what else. We're right by the World Trade Center. When the World Trade Center was hit on 9/11, part of it fell on one of our buildings. And that's one of our buildings that got damaged in it. And the building was eventually torn down and rebuilt. And there's the new version of it. And we have a number of research programs. One of the nice things about BMCC is we actually do have quite a bit of money. And there's a lot of undergraduate research programs where students can get funding in. There's the BMCC Foundation Fund for Undergraduate Research. That's a 1 semester long, I guess, experience for them. We have something called C-STEP. We have the CUNY Research Scholars Program, which is really nice. The students get like $5,000 or $6,000 for that. And that's lasts for about a year. I always have students in that. There's LSAMP, there's something called Minority Science Engineering Improvement Program Retention and Improvements in STEM Educations, which is MCF RISE grant. We had a big grant for that. I think the grant's expired now. We have a STEP for high school students. Every once in a while, I'll mentor a very good high school students. We're right next to Stuyvesant High School, which is one of like the two premier high schools in New York City. And these students are really, really good. Like I had a few semesters ago, I had a young woman, and she was like a freshman or a sophomore in high school. And she came to me and she wanted to learn about differential equations and different things like that. So it's a really advanced high school. And we have a BMCC honors program. Students don't get paid any money, but it runs every semester. And so it's a lot of fun to work with the students. For the research programs, usually it's a project that I really pick out based upon what I'm interested in, because the students are getting paid money. And with the honors program, what I do is I ask the students, what are you interested in? And usually I can figure out something that they're interested in that I could mentor them in. Usually the students are interested in things related to engineering or math or physics or biology, and I can mentor in those areas. Okay. Here's what I'm just, this is a grant we won a little while ago for $1 million. I think we also got a grant for $30 million from Jeff Bezos's wife. She had a lot of money. She gave us $30 million. So we're trying to figure out ways to spend it, which is nice. Okay. This guy received another grant. We get a lot of grants. One of the nice things every year is we have the this research symposium. And this is my favorite day of the whole year.
Involves the entire BMCC community. All of our students are involved to come see the work that the students have done. The researchers have done, all of our faculty involved. We have people judging the events from all over the college. It is probably one of the largest events at the college and is definitely a community building event at BMCC.
And I'm glad today my three students are presenting three different researches in the area of biomedical engineering. They try to weld unweldable materials. And I believe that every student should be involved in the research.
I love this particular project because I really wanted to do cancer research. Cancer research has affected a lot of my.
So so this is we have a showcase of our students doing research, and it's just the nicest day of the year. I always chit chat with all the students doing all these wonderful projects. It's just really nice thing, and it gives them a chance to show off. And some of them are really good, and some of them are, they're just trying. And if your school doesn't have something like this, I highly recommend it. Okay, and okay, so here's some resources for ideas for projects. Semiote, of course, is really good, of course. And you have the Cody Journal, which is also a really nice source for projects and for things related to differential equations. And so what is undergraduate research in a two-year college? And original research and results in deep technical mathematics requires a lot of training. That's what PhD programs are for. You just can't do that with students at a two-year college. Not really. But they can have a research experience, and that means like open-ended problems with no single correct answer. You can have them read a research article or learn about the professor's ongoing research and then reproduce, explain, or help write up results. Some of them can write computer code. You can have them modeling various phenomena, maybe creating or tweaking or applying a model that you've already come up with or that you found in a journal someplace. And also you can expose them to grant writing, conference presentations, and networking. And sometimes just having them around in the research environment is good, or just to sort of hang out and chit chat with you. It can be very important that they can just sort of pick up on like what is doing research about. It's like, you have a problem, you don't know what the answer is to, and you just try this and you try that, and then you call up a friend or somebody, a colleague, and they give you a suggestion, and you look for stuff and you don't know exactly what you're doing. And then they get a sense of, do they like that, or is that interesting for them? Okay. All right. And what are the problems with undergraduate research? Well, one of them is like, how do you choose a research assistant? This is really, really tough. I don't know the secret to it. Do you base it just on their GPA? Well, it helps if they have a high GPA, but that's not everything. How about enthusiasm? That's probably the most important thing, that they actually are enthusiastic and want to do work with you. And I would take an enthusiastic student over a smart student who doesn't have time to work, or a student who maybe doesn't have the personality for to work with me. I like students who they want to do the work, and then they're sort of enthusiastic about it and they're interested in it, and that's the key thing, I think. Okay, another problem, and this is a real one, is research versus classwork versus job versus friends and family. And here's the dilemma. Usually the students who are more ambitious are doing a lot of things, and so they want to do a lot, but they also have jobs, and they have family obligations, and they have class obligations, schoolwork, and so all of this sort of is competition for you. And so you might be like, I want you to work on my project, and they're like, yes, professor, I will, but I have my job, I have my this, I have my that. And so that's one of the real problems, is that even if you pick a good student who wants to do work, sometimes just their life gets in the way of them being able to do work. That's the main problem. Ultimately, the research you're doing might be important to you, but maybe not so important to your undergrad research assistants. And then, of course, students not knowing enough math. What takes you a couple of minutes to figure out may take your students half the semester. And so you always have to tell yourself that, the students, they're not going to be able to work at the same speed that you're working at. Is that the important thing is that they have like a good time, and that they feel like they're getting exposed to research and that they're doing something. And even if they're a little bit, slow at it, it's okay. These are not postdocs or something. Okay, so be realistic. Your research assistants are just beginners. So a good experience is more important than getting good results. That's the key thing to remember. Okay. There are obviously a lot of benefits of undergraduate research. The students usually enjoy it. They learn how to do research. The experience sticks with the students. They remember doing research with you long after they forget all the math they learned. 5 years, 6 years later, they'll probably remember the research project they worked on with you, but they're going to forget everything else that they learned unless they keep working on it. But they'll remember the experience of working with you. And this means a lot to a lot of the students. The students gain confidence, pride, a chance to show off, and often get paid for it. And the research experience looks great on their CV. So I'm a big fan of it. Okay. So what are the benefits to you? Well, you enjoy it. Looks good on your CV. And the students will sometimes do useful work for the professor. And having students is motivating. I always feel proud of my students. That's absolutely the truth. Every single one of them, I just feel really, really proud of them. It's a good feeling. And I remember all of the students I mentor. And, I keep in touch with them. And as their careers go on, it's like, oh, now they're doing really good, and then I'm happy. And then if they have a setback, I console them. Okay, so almost all the research projects I've supervised involve differential equations. Why? Because the students who take differential equations at a two-year college tend to be outstanding and serious and have more mathematical maturity. Also, most of my DiffEQ students are interested in engineering or science, and they realize the need to understand or to be familiar with modeling. And the students can use their physical intuition to understand what should happen mathematically. They may not understand the math, but they can understand what we're trying to model. And most of the students aren't ready to do research in pure math, even the math majors. They haven't had analysis, abstract algebra, topology, but they can do some sort of application. Okay. So now I'm just going to go through a list of some of the projects that I've mentored students in. And the very first project, well, I don't know if it's the very first, but one of the first projects that I've mentored a student in was this young woman, Nanda Meloja. And we did a project on the Euler and the Runge-Kutta methods in differential equations. And she graduated from Hunter College in 2014. She went on to Columbia University in 2017. She got an MA in actuarial sciences, which is like insurance type stuff. And currently, at least last I checked with her, she was working with New York City Office of the Actuary, designing and preserving pension plans for city employees. And so I've contacted her and I asked her about her thoughts on undergrad research projects. And I've done this to a lot of students to get feedback to see years later, what do they think of the research experience? And this is what she wrote. I would recommend to everyone who has a chance to take that opportunity and make the best out of it. Not only you learn more than just what the syllabus covers, but you also have a competitive advantage when it comes to applications for graduate programs. This is a very practical young woman. She was like, she wanted to get ahead. And so she did a project with me, went on her CV, and, she was able to make her career goals come true. This student over here, Evgeny Goldstein, we did a project on numerically calculating orbits, differential equations in the three-body problem. So you're all probably familiar with the three-body problem. This is like you have maybe the sun and the moon, and well, you have the sun, the earth, and the moon, or you have the earth, the moon, and a satellite. And so what we did was we wrote some programs to numerically solve the three-body problem, and that was his project. And regarding this is what he wrote back. Regarding the research experience, I think it is a great way to learn to think out of the box and to apply mathematics discipline to solving engineering problems. And he's working as a structural engineer for Sikorsky Aircraft, which is part of Lockheed Martin. All right. This is Pete Weeks. He came to me in 2013. He wanted to be a civil engineer. And so I came up with a project for him on catenaries. So a catenary is a curve, like in these pictures, is formed when a flexible object hangs freely, carrying its own weight when suspended from only 2 points. And so his project was on the catenary equation. And over here on the, on the left, this is his sister's chain. And what he did was he hung it from a notebook, a spiral notebook with some graph paper. And that was his data. And then we compared it to what the prediction from the model. And the model predicts how the chain will hang very, very accurately. And that was his project. It was really an interesting project to do. And it's easy to do. What do you need? You just need a little chain, a little spiral notebook, and a ruler or some graph paper. You don't even need a ruler. That's all it takes. And you get a nice little project out of it. And he's currently building gigantic structures. He's like sports stadiums, concert venues, that type, not like little houses, but like these big gigantic things. That's what he's building. And every once in a while I get in touch with him and he's like, "Oh, professor, I'm using this stuff from differential equations class." I ask him questions and he says that very often we double check the computers by hand, solving the differential equations. That's what he says. So this is Pete Weeks. And this is Gregory Rodriguez. And he did a project on differential equations and ecological models. And he went to NYU on a full scholarship, and he's currently back at BMCC. He likes teaching, and he's teaching there as an adjunct, but he's also supposed to be doing a postdoc or a doctorate, I forget which. I just saw him the other day. And the project that he's working on is an interesting project. This is where the NASA or everyone's sort of worried about what happens if the Earth gets hit by a large meteorite. It's like we don't want to be wiped out like the dinosaurs. So there's this project, I forget the name of it, where they're where they're shooting something against an asteroid and seeing how much it's going to move. And he's working on that project. That's I think he's doing a postdoc, and he's doing some of the calculations for that. So he's a really nice guy. Whenever I see him, he's always telling me about the asteroids and shooting things off of them. Okay. This was Young-Wook Choi. This wasn't the differential equations project. This was a Korean young man. He could hardly speak English, but he wanted to do a project with me. And we were only in, this was like a pre-calculus class. Usually I don't work with students at the pre-calculus level, but he wanted to do it. So I said, okay. And he came up with a project, Mathematics in Our Daily Lives. And one of the things he investigated was why are manholes circularly shaped? And the answer is so that it doesn't fall in the hole. If you have like a square shaped or rectangular shaped manhole cover, it's easier for it to fall in the hole. But a circular one, as long as the lower rim is a little bit, smaller than the upper, it's not going to fall in. And I didn't know that, so I thought that was like a cool project. And when he presented his work to the committee who judges these students on these types of projects, they really liked it because they understood what he was talking about. And one of the faculty members, these faculty members are smart, but they're not drawn from mathematics. They're drawn from like all over the school, like literature and history. And they're like, they told me this was their favorite talk ever because they actually understood what he was talking about, because it was a fairly elementary talk. but it was interesting. It's like, why are some things circles? It was a nice talk. Okay, so you don't even have to have like really even advanced students to have interesting projects. I was very proud of him because his English was just very, very poor, but he's like, I want to do this. And so he did it, and it was very good. Okay.
Okay, Chris, take about 5 more minutes. Go ahead.
Okay, so all right, so this is a project that I did on geez, let's see, I have like a lot of them. So this is a project on using differential equations to model the kinetics of heavy metal absorption onto tea leaves. And this project was kind of interesting. It also some Korean students, they came to me and they wanted to work with me. I didn't have any money for them. I didn't have any honors projects because I was already working with some students. I told them maybe you can find another professor, and they kept coming back to me. And one of the students had been working with a chemistry professor at BMCC on the absorption of heavy metal onto tea leaves. And so I was like, oh, tell me about it. So I got interested in it, and I talked to the professor, the chemistry professor, who had the data but didn't have the model for it. So I developed a differential equation model for understanding the way that the heavy metal gets absorbed, not absorbed, but adsorbed onto the tea leaves. And the model was pretty good. It was able to predict the how it worked. It was really nice experience. And this is another version of it, a little bit the second sort of iteration of it. And I'm going to skip over her. She was working on the gravitation. She ended up this student worked with me. She was Nurses Without Borders or Doctors Without Borders, and she wanted to do a project with me. So we did something called the ideal rocket equation. She eventually went on to Columbia University and worked on the gravitational wave machines, not the ones in the US, but the ones in Italy. That apparently they were building one over there, and she said she really liked it. She was in Tuscany. She said, "What's there not to like? I'm in Tuscany, working on a machine to detect gravitational waves," and so she's really nice also, and just a very smart young lady. Okay, let me jump ahead to. I'm not sure which project I should do. There's a lot of them. Okay, I'll do this one over here because this is sort of in some sense the best project. This is Newton's law of cooling, and Marvinville Honor Project. It became part of my a webpage on differential equation modeling. It's Newton's law of cooling, and it's the easiest project to do in the world. You just need some thermometers. You can buy these thermometers for about $10 each. And you need a watch, but you can just use the clock on your computer. And you put some hot water in a cup, doesn't have to be a measuring cup, and you just take the readings, and you just keep taking readings and you keep taking readings. This guy didn't know when to stop. He did it for like, I don't know, 8 hours or something. I only wanted him to do it for an hour or so, but he didn't give up. That's why the light's changing in the room and stuff. And then you get the data, and you can then use it to figure out the K from, or the constant from Newton's law of cooling, and you can make the prediction, and you can see that the data, the red dot, matches up with the what Newton's law of cooling predicts. So this is probably in my opinion, one of the best projects to do with students because it's easy, it's cheap, and it works. And Newton's law of cooling is so simple. You do that at the like first or second week of the semester. So this is a good project. I think I'll end here because I'm running out of time. But I have a lot of other projects if anyone's interested. All right, thank you, Brian, so much for inviting me. I really enjoyed being at the conference.
Thank you. Any questions or comments other than some kind of pun getting ready for the math thing about way cool projects? Okay.
Okay. All right. Bye-bye then.
Yes. One of the things you should know is if you visit the campus of Borough of Manhattan Community College, you hardly hear English spoken in the student lounge. This is a college where people come to America or are living in the second generation families. And this is education in New York City traditionally has been a way up. And first, after my first meeting with Chris, I went to Manhattan College. He's at the Borough of Manhattan Community College, but Manhattan College is a private school, believe it or not, in the Bronx, New York, not in Manhattan. And there were 3 students, Asian students, and one of them had just come to America a year ago, and he had index cards, and they were doing a poster sessions. And I'm going, would I go to Singapore and do a poster session on mathematics and Chinese after being in the country for a year? I don't think so. They're courageous students, and I think Chris fosters that in them, and we all should admire the kinds of things he's doing. And I know a number of you do that, but I think he's exemplary in that, and I'm glad to call him a friend. But okay, thank you, Chris, very much.
Yeah, just a follow up on that. Yes, exactly. That's exactly my feeling. These students are very brave. They come here from all over the world. And you have students that come from Africa and they want to go back, and some of them, they want to fix, do civil engineering projects. They'd be like, if we would just have a road for our village, it would make life so much better and stuff. And others, they want to make a new life in the United States. It's really a nice thing. And I do have a lot of admiration for my students. So, all right, that's all. Yeah.
All right, thank you, Chris.
Okay.